Hi everyone, here's Ray from UC Santa Barbara. I'm going to introduce my work guiding instruction-based image editing via multimodal large language models. This project is also collaborated with Apple. Instruction-based image editing can support straightforward human comment such as change the overall style or replace a part of the photo. However, there is a challenge, where is the gap between guidance of instruction and visual. For example, we have a pizza image here, and the instruction is improve its health. This case is super challenging because the model cannot capture what health means for a pizza, or even how to make it more health. In contrast, the strong multimodal large language models, aka MLM, can contain latent visual knowledge. We can ask what will this image be like if improve its health, and the answer is quite helpful, including healthier ingredient and side of fresh salad. This explicit description can help provide a concrete intention to guide editing. Although the response is in general helpful, it is usually too long, sometimes redundant, or even has irrelevant information that may mislead the editing. In this paper, we present MLM guided image editing, aka Magi. We first adopt a summarization model to summarize the wordy response from MLM into concise yet expressive instruction, and we treat this expressive instruction as the ground truth to train the MLM, so that given the instruction and image, it has to auto-regressively derive this explicit description. We then append several visual tokens after that, which is kind of placeholders as the latent imagination about how MLM thinks what may the edited image be like. However, the hidden states of those visual tokens are still in the language modality from the MLM. So we have an added hat here, which is a lightweight transformer that can project them into the visual modality. Finally, the diffusion model can condition on both input image and the guidance from the MLM to perform reasonable image editing. During training, we can freeze the most expensive part, the transformer blocks, inside the MLM, and achieve a parameter-efficient end-to-end optimization on a single node. We train Magi on the iPrompt-to-prompt dataset, which contains 1 million synthesis image pairs with instructions, which is the same as the baseline. We consider various editing aspects, including Photoshop style modification on EVR and GIER, global photo optimization on MA5K, and local manipulation on Magic Brush. The evaluation is conducted as a zero-shot testing. For the metrics, we use the traditional structure similarity and the features similarity from clip or VIT between generated images and ground truth results. For photo optimization, we also have ellipse distance to compare the overall style between output and ground truth. We apply the popular instruction pixel to pixel as our baseline, which adopts clip to understand the input instruction for image editing. Here are the results. On EVR and GIER, our Magi can have a higher dyno as well as SSIM similarity. From the qualitative comparison, we can draw lightning and make the water reflect. We can also remove the Christmas tree in the background, but the baseline instruction pixel to pixel just fails. For MA5K, we achieve a lower ellipse distance, which supports that our result is globally more similar to the ground truth, and we can actually brighten the image, but the baseline just produced the same as the input. On Magic Brush, we put the glaze only on the donut, but the baseline even makes the whole picture into the pink color. So while our Magi is helpful, we calculate the clip score, and it shows that our expressive instruction is more aligned with the input and goal image than the original instruction. Magi can provide more explicit and concrete editing guidance, such as the dog will play with the stick, or even chew on it if we want to close its mouth. In summary, we introduce Magi to bridge the gap between guidance for instruction-based image editing. Magi contains the MLM to derive concise expressive instruction, and the diffusion models then performs editing via the latent imagination. We show that Magi can support various applications, including Photoshop style modification, global optimization, and local manipulation. We have open sourced our code with a Hugging Face demo. Everyone is welcome to give it a try. Here's Ray from UC Santa Barbara. Thanks for your listening.